So today we have our second special triangle, the famous 30, 60, 90 triangle. It's called a 30, 60, 90 because of course it's a right triangle. And it's got a 30-degree angle and a 60-degree angle, and then there's the 90-degree angle. So you remember we learned a long time ago that short sides are across from short angles and big sides are across from big angles. So the shortest side is going to be across from the 30-degree angle, and in all right triangles, the longest side is across from the 90-degree angle. There's a relationship between the shortest side and the longest side. And if you look at it, you see x and 2x. What that tells us is that the longest side is double the shortest side. So if we take the shortest side and times it by 2, we get the longest side. Now here's the tricky part. If we want to get this like medium side, we take the short side and times it by the square root of 3. And that's just how the pattern works. Times it by the square root of 3 to get the side across from the 60. So 30, 60, 90 triangles are right scalene triangles. Right because they have a right angle, scalene because every side is different. So again, you can follow the pattern or you can use Pythagorean theorem, but it's easiest to just follow the pattern. The shortest side is across from the 30. What did we learn? The longest side, we take that side and times it by 2. And to get the side opposite the 30, we take that side and we times it by the square root of 3. Now I'm just going to show you that that does work in the Pythagorean theorem. 5 squared plus 5 root 3 squared does equal 10 squared. 5 squared is 25. 5 root 3 squared is 5 root 3 times 5 root 3, which is 25 root 9, which is 25 times 3, which is 75. And so it is true, of course, that 25 plus 75 is 100. You don't have to do that. All you have to do is follow the pattern. Now, sometimes they give you the side opposite the 30. Sometimes they give you the longest side first. So if they give us the longest side, what would the side opposite the 30 be? Again, the relationship is this side is half of that. So this would be 3. And then I would take that side and times it by the square root of 3 to get the side opposite the 60. It's probably trickiest when they give you the side opposite the 60 and you have to get that short side and long side. And all you really need to do is take away the square root of 3 for the side opposite the 30. So if the side opposite the 60 is 8 root 3, side opposite the 30 is 8, and then side opposite the 90 is 16. And once you get it, really just have to orient yourself because the triangle changes around, the 30-degree angle changes around. But if you say, okay, this is my shortest side, if I double it, I get the longest side, and then multiply by the square root of 3 to get that medium side. If they give me the longest side is 12, I'm going to cut it in half to get the shortest side, and again, multiply by square root of 3 to get the medium side. Here, this 4 root 3 is across from the 60. If I just take away that square root of 3, I get the shortest side, double it to get the longest side. So if that's too much for you, you can always go back to Pythagorean theorem every single time, but I think you're going to catch on to the pattern and just orient yourself with where the 30-degree angle is. The last one is a little story problem, 24-foot bleacher. Of course, that is the hypotenuse, so the side opposite the 30 would be half of that, or 12, and that's all you have to answer, so 12 feet. So there is the pattern for 30, 60, 90 special triangles.